What's up to peoples? I've got this small elephant nightlight here, and this is something that we've had since our kid was a baby. We used to use it in his room to, just kind of provide a little bit of light at night. But as he's gotten older, we no longer use it for that, and we actually use this in our living room just to kind of like light up the walkway there where the front door is. So if somebody comes in like at night or whatever, it's just kind of dimly lit up, but at least it provides a little bit of light so you can see where we're walking. But unfortunately, this one's no longer doing its nightlight duties. And normally I wouldn't really find anything like this like too interesting, at least not anymore. When I was a kid, I did find these like automatic nightlights a lot more interesting. But there's something about this one here that actually caught my attention, and I'm bringing you along with me to find out why exactly it is. But if we take a look at another one of these automatic flashlights, or not flashlights, night lights here, we see that it's got this, it's a cadmium sulfide photo sensor there. And the way those work is depending on the amount of light, it changes the resistance of the device. And now this here is a more modern one, but when I was a kid, I was actually fascinated by these automatic night lights here because the only ones I had previous experience with was these switched ones here, or something like this, where you manually have to go down there and turn it on if you want it to be on or whatever. But then when these started hitting the scene, I I actually asked my dad to buy me one because I wanted to take it apart, see how it works and all that. I always liked taking stuff apart when I was a kid. But if we plug this one in, I've got this extension cord here. We see right there, it's not on. This is a little projector. This one uses an LED, so it's a lot more modern, but it works pretty much the same way. If I start reducing the amount of light that hits that sensor by covering it here, we see that it can get brighter or dimmer depending on how much light is hitting that sensor. So if it's like completely dark, then it's really bright, but it's just like a little bit. So that's it just kind of reacts like that. It's a very simple circuit usually. Like it'll be like a triac or a diac, or not a diac, but like a SCR or something. And then this is wired in a way where once the resistance increases, then it allows it to light up. But this one here does not use a cadmium sulfide sensor. This appears to have either a photodiode or a phototransistor. I don't know which one. So if we plug this one in here, I can actually show you what it's doing. If I cover up the light, you can see that right there. It kind of flashed a little bit, and the LED is like super dim. So it's still working, but it's like extremely dim for some reason. If I let it go, I'll cover it up again. See right there, it kind of flashed. But this one here appears to have some sort of a like hysteresis. So it doesn't completely turn off, or it doesn't like fade in or fade out. It's either completely on or completely off. So I want to take it apart, see what's actually inside of here, and if I can get it working, then that's a bonus because we can still use it. So let's get a screwdriver, see what's up inside. Okay, so first of all, we're gonna pull the elephant here off the top. Point. There he is. We're just gonna set him aside, not break him anymore. And you can see in there, that's the white LED. And it just has 4 Phillips screwdrivers. Four, four Phillips screws. Now that's the model number right there. It's EDNL01. And let's take these off. All right, that's all 4 screws removed. Now let's see. Let's see. Oh, okay. So this one uses a capacitor there, probably as the voltage dropper. It's got a fuse, resistor, and a capacitor. This one's already a lot more fancy than some of the other ones. Oh, look at that. That board is broken. So I wonder if we accidentally broke it at some point. Maybe that's the problem. So let's see if we can pop this out. I'm going to push it up against the... Oh, okay. Never mind. This should just pop out. It's those pins from the plug there. They're friction fit. So this board should just pop out. Let's get a screwdriver in here. Let's see if we can... Yeah, there it goes. Cool. All right, big reveal. Let's see what's on the other side. Drum roll, please. Huh. Yeah, so this one actually has a rectifier, another resistor there, several transistors. Actually, that one right there says U1. Dang, this is a lot more complex than I thought it would be. But that broken board there doesn't appear to be a problem because it doesn't look like it goes very high. It's just kind of localized to that area. There's nothing there. So, well, I guess we're going to have to do a little investigating. Okay, so here's a much closer view here with the microscope. And we can see that we actually have a 431 here. So that's going to be an adjustable shunt regulator. And we have a couple of transistors here that are marked J6. I'm going to have to look that up and see if I can figure out what those are. And then we have this other one over here that says 2TY. No idea what any of this stuff is off the top of my head. But a 200 ohm, or not 200 ohm, but that would be a 20 ohm resistor. Looks like we've got a 30K. I'm not sure what that is. I don't remember what the C means. Is that 310, I'm guessing? So that would be a 31 ohm. 05D, 102. That's going to be a 1K. This is going to be a 1.5K. 100K. 26C. Don't know. And then a 474. So that's going to be 470 ohms. So it looks like this side here is going to be the live from the mains. That goes through a fuse. The fuse snakes over here directly into the rectifier. The opposite side here, the neutral, goes to this resistor, and it's also in parallel with that capacitor there. So it looks like this resistor here might just be used as a bleeder resistor for that capacitor. The capacitor there is the one that's actually doing the work of powering the device. So we'd have rectified mains over here. That goes to a resistor that we see on the other side here, this big power resistor. And that goes to the rest of the circuitry. The negative side goes over to this side here, capacitor, resistor, the shunt regulator, and it goes to one side of the white LED, which that would be the cathode side. So it looks like it's the anode side. That's the one that's being switched. So this here is probably going to be a PNP transistor. So these, I'm guessing, are probably going to be NPNs. One of them goes to the sensor here, and I'm pretty sure that this is probably a photo transistor because I don't see any markings here that says D for this part. But we have a Q3 here, a Q2 here, and a Q1 here. Well, the other side has a marking there, but I can't tell what it is. Looks like maybe CD or CDS1, but that's not a cadmium sulfide sensor. We can zoom in on it right there and see what that actually looks like. So it looks like it's got 2 pins, or I mean, it's going to be like the base, or not the base, but the where the substrate is mounted to. That's going to be like the negative side, and then it's got the 1 pin coming out of the middle there. We see that it's got that tiny little block off to the top left. I'm guessing this is going to be a photo transistor because when it's a photodiode, it's usually like an entire like little block, and I'm not sure if I'm going to be able to get any closer, but we can kind of see like some squiggles looking in there. So I'm guessing that this is a basically a transistor die that's been mounted in a clear package so that it functions as a photo transistor. But since this circuit is pretty out in the open here, and it's pretty easy to see where stuff goes, I think we can reverse engineer this and maybe figure out how it's supposed to work, and then maybe I can figure out what's wrong with it. All right, all right, all right, people, check it out. We have here le schematique. That's French for the schematic. I think. I could be wrong. Anyways, so I reverse engineered the board, and I think I got everything right. I kind of went through it, and I don't see any problems. So everything should match exactly what's on this little board here. So let's take a look and see what we got going on. On this side, we have our line and we have our neutral. So the line goes through a half amp, 250 volt fuse that instantly goes into the bridge rectifier. On the other side of that bridge rectifier, we have the neutral That's in series with this capacitor here. That's a 470 nanofarad 400 volt metal film cap, and it's got that resistor in parallel. And like I said, this is most likely just a bleeder resistor, so that this capacitor here doesn't store a charge when it's been unplugged for a bit. And that's just a 470 k ohm resistor. The positive from the bridge rectifier goes through a 100 ohm resistor that appears to be maybe like a 1 watt. This whole thing is rated for like half a watt, so I think that's a 1 watt resistor. And that goes off into the rest of the circuitry. The negative from the bridge rectifier goes, and that's obviously like the ground plane for the circuit. So coming out of the bridge rectifier, it's not going to have like regulated voltage. It's basically just going to be whatever this is like putting out. So what they've done here is they're actually using this TL431 shunt regulator, and that's in parallel with the positive and the negative line coming out of the bridge rectifier. There's a little capacitor here. It's marked C4, and I don't know the actual value of that. It's a little tiny chip cap like right there, and I'm not going to bother to pull it off the board to try to figure that out because that's not really important. So that's closest to the output here from the bridge rectifier and this resistor, so that's why I put it here in the circuit. And the adjustment line from the shunt regulator is connected to the center point of these two resistors here. And one of them is a 30K resistor. The other one is marked 01C, and I don't know any of these off the top of my head, so I had to look it up. But on DigiKey's website, they actually have this, it's an SMD resistor code calculator, and this here would be the EIA 96 codes. So if you put in 01C, down here we see that that is a 10K ohm resistor. So I'll go ahead and put that right there as a 10K ohm resistor. Now, I've never really used one of these TL431s myself as part as like any regulator or like a shunt like this. So I'm not entirely sure of like the calculations required to set the voltage for whatever you want to output. So I kind of went online and I looked up like a TL431 calculator. And I found this on Texas Instruments website. They have a little design calculator. So I downloaded it, and you end up getting this TL431 XLS file. And I looked at it, and I'm like, I don't feel like learning anything new today. So I said, forget that. Not going to deal with that. So I'm not entirely sure what the voltage between these rails is supposed to be. But, I mean, we see that it sort of does work. So I don't suspect that this would be an issue. And the other thing is that I don't know exactly which TL431 this is because there's several different variations. And when I looked up the pinout for that one that's on there, obviously I don't know which one it is, but this seems to make the most sense that it would be wired in this configuration. I mean, there's nothing else to denote like what type. All it says is 431. That's it. So anyways, so then over here at these points, we're going to have, whatever voltage this is set at. And then there's this 100 microfarad capacitor. That's an electrolytic. And that's that dude right there. And that's going to be basically used as like a smoothing cap. So whatever voltage this is regulating to, this is going to kind of like hold that charge. And so this is pretty much like all the important stuff over here on this side. That's our sensor there. And on the board, it does say CDS1, so I'm assuming that maybe this board was designed to use one of those cadmium sulfide photosensors. But on this board, like I said, that looks to be, for all the world, like it's a phototransistor. And it kind of makes sense by the way it's wired. So it looks like the collector goes off to the positive side here, and then the emitter goes over here down to control the base of Q3, which is an NPN transistor. And so for a NPN transistor, we put the positive here on the base, which on a SOT23 device like this is going to be this pin right here. And then the collector, we're going to attach the negative lead to. That's going to be right here. So we're going to get a diode drop there. And my multimeter just ran out of batteries. Let me go exchange those real quick. Okay, I got 4 fresh batteries in my multimeters. Let's go ahead and try this again. So I'm going to put the positive lead here, the red lead from the multimeter, onto the base of this transistor. And then I'm going to put the negative onto the collector, which should be that one. And we see right there, we've got on the right top side of the screen, we have a voltage drop of 0.7105. So I'm going to take this negative lead and put it onto the emitter of the transistor, and we see we got 0.7141. So yeah, that's basically, it's an NPN transistor. And let's go ahead and check this one here. So same thing between this is the base on this side. Let me just flip it over. So we got the base, and we have the collector right here. We see we got 0.7103, and then on the emitter, 0.7135. So yeah, these are both NPN transistors, and unfortunately I couldn't really find a definitive number for those or anything like that. So all I can say is that they're NPN transistors. Now this 2TY here, this is definitely going to be a PNP transistor. And so for that one, we're going to hook up the black lead or the negative lead here to the base of this PNP transistor. And then I'm going to take the positive lead, and I'm going to take turns connecting it to the emitter, which would be this side. And we see we got 0.72243 right there. And on the collector, we have 0.7212. So both transistors here appear to be fully or all three transistors appear to be totally fine. I don't suspect that those would be a problem. But anyways, getting back here to the schematic. So all transistors appear to be good. So let's assume that it's either daytime or the lights are on or something, and this LED here is off. So what would be happening is this photo transistor here would be receiving light, which means it would be active. So it would be allowing current to flow from the emitter to the collector here. What that's going to do is it's going to pull this line here to the positive side. And this capacitor here, it's another little tiny chip capacitor on the board. I also don't know its value, but it's pretty much looks like it's just being used to kind of like smooth the current here at the base a bit, so it's not like fluctuating or anything like that. So since this line here would be getting pulled high, then this transistor is going to be getting turned on, which is going to pull this side here low because the emitter here is going to the negative side through this 1K resistor. And on this side here, we see we also have two more resistors that are labeled with that EIA 96 marking. So let's go ahead and figure out what these are. So this one here is 01E. So let's put it here, 01E. That one there is a 1 megohm resistor because it's 1 million ohms basically. So we've got 1M there. And now for the 05D, we have 110 K ohms, or because it's 110,000 ohms. So there we have 110 K ohms, except there we go, that's better. All right, so that's going to pull this line, like we said, down to ground, and that's going to this 26C resistor here. 26C, that's an 18.2 kilo ohm resistor. That almost fits in there, but okay. So now we've got all those resistors labeled. The rest of them they're just marked what they are. So this one here just says 20. That's just a 20 ohm resistor. Anyways, so if we're pulling the line or the base of this transistor here down to ground, that means that this transistor here is not going to turn on because this is an NPN transistor and it requires a positive current on the base. So that means that this line here is going to be allowed to get pulled up high. So the base of the PNP transistor is going to make this one so it does not conduct. That means that there's not going to be any current flowing from the positive here through the transistor, the resistor, and the LED, which means that this resistor or the LED is going to be off. So that's our night light turned off when there's light shining on that sensor. Now when it turns dark and there's light no longer hitting this transistor, then it's not going to conduct current between the emitter and the collector here, which means that this side here is going to be able to get pulled down towards the negative or ground here. Because we can see this resistor here is a lot smaller than this resistor here. So that means that this transistor is now going to get turned off. It's not going to conduct between the emitter and the collector. And that means that there's no current flowing through here. So that means that the base of this Q1 transistor, that's going to get pulled up high towards the positive here through this 18.2 K ohm resistor, which is going to allow it to conduct between the emitter and the collector through this R11 1 K ohm resistor here. And that's just a resistor coupled here to the base of Q2, which is the PNP transistor. So that's going to pull the base down towards ground, which is going to allow this transistor now to conduct because it's the opposite of an NPN transistor. So current's going to flow through here, through the LED, the resistor, and the transistor, which is going to allow the LED to turn on. And yeah, that's pretty much it. So I don't see anything on the board that looks obviously burnt or damaged in any sort of way. So my suspicion is that the problem might be right here. This 100 microfarad capacitor is, in my opinion, the most likely culprit of why it's not shining as bright as it should, because it does appear to be like functioning. What could be happening is that it's just not storing enough of a charge to keep that LED lit brightly. As we saw when we block the light to the sensor, it kind of gives like a little brief like pulse of light, and then it kind of dims again. So I think that might be just because of whatever charge is stored in here is enough to kind of make it blink with a little bit of brightness just for like a split second. But once it drains and there's a continuous load on it, the shunt regulator here just can't keep the current like high enough to maintain that LED brightness. So if I get my little EE meter here, we can check in circuit that capacitor. And so it would be like this. It's set to 1 kilohertz. I don't think it's going to matter here, but so we can see that once it settles down, it's got it looks like it's got a capacitance there of about 77.5 microfarad when it's supposed to be 100. I'm going to take it out. We'll measure it outside of circuit, see what it measures, and then I'll dig around and see if I got another one. I think I do have some of these like brand new ones in a package there. Swap it out, see if it works. All right, so the capacitor is out. We can check it with both my Agilent multimeter in capacitor test mode here. Let's see what it says. So you'll see it right there on the top right. All right, so that says almost, yeah, that's pretty close to 100. I mean, it kind of jumps around a little bit depending on, maybe these aren't making good contact. So, well, shoot, that looks a little too close to 100. Let's check it with the EE and see what that says. I'm just gonna touch it like this. 78.89. See what happens if I change the frequency. I'm not sure what frequency this should be tested at. 100 hertz, 88.51. 120, 87.49. Yeah, none of these different frequency settings here make it read anywhere close to 100. I'm kind of leaning towards trusting this one a bit more than my Agilent multimeter. Well, how about we just try swapping it out and seeing if it works at all. All right, well, these are my options. I've got this 10 volt, 100 microfarad Rubicon cap here. That's considerably longer than the original one that was in there. And unfortunately, this would not fit if I put it in there. So that's kind of out of the question. My only other option is, or stuff that I have on hand, is this 100 microfarad 6.3 volt Rubicon cap, or Nishikon, which is almost the same height. It's actually a little bit shorter, but I think it's a little bit wider in diameter, which is not a big deal. It will fit. Now, these are not 16 volt caps. However, I don't believe that they would be running anything in here anywhere near 16 volts. As we saw, the resistor there is only a 20 ohm resistor going to that LED, and this LED is not like a high powered resistor or anything. I mean, it's not even meant to be like super bright. It's just meant to like illuminate a little bit at night. So I kind of doubt that the voltage is going to be that high. So I think what I'm going to do is I'm just going to YOLO it, stick this in there and see what happens. We could even test the voltage at the capacitor and see what sort of voltage reading we get anyway. So that's what I'm going to do. Let's just see if it works. Okay, so I've got the new capacitor soldered in there. I left the leads long so that I could clip these test leads to it. That's going to my multimeter, which I'm actually going to set to a DC mode right there. Okay, and the only thing that sucks is that in order to test this, I am going to have to try it out with mains voltage. However, I do my own stunts here, people, so don't try this at home. I'm going to, right now, there's nothing here. The other leads are going to nothing. So I'm going to hook those up to a cord. I'm going to just sort of like flip this over here so we have access to that sensor there. And let's see what happens when I power this up. I'm actually going to rearrange these here because the live actually goes into the fuse, and that's usually the black conductor. And then the white one here I'm going to put to the neutral. So there we go. Now it's correct. Okay, I've got the alligator leads here hooked up to a cord that's going to be plugged into the mains. And I can actually pull it up here. You can see it right here. It's clipped to the other end of this. And then I got an extension cord here, an outlet. Let's go ahead and plug it in and see if anything goes pop. Here we go. 3, 2, 1. All right. Oh, okay. See, voltage up here, 3.343. So, I mean, that's about probably, yeah, what I'd expect, something kind of low. Now I need a way to cover that sensor without touching the board. All right, I've got a plastic cap from a lubricant can. Let's see if this is going to be enough to trigger it. Nope, I think it's... No, actually, the LED does light up, but it's not very bright, and we can see that the voltage dropped down to 2.8, and it's still going down. So that capacitor does not appear to be the problem. And once the LED turns back off, we see that the voltage there jumps up again. All right, so I was not planning on going this in depth with this thing because if I can't get it working, it's not that big of a deal. Like, we can just, if we really need to or want to, we can just put another little nightlight on the walkway. But since we're already here, you know. So I've got this power supply here. As you can see up there at the top, I'm having supplying 3.3 volts. So I'm basically just injecting that directly into where that capacitor is. So that would be the voltage present after the shunt regulator. So let's see what happens there when we cover up the cap, or when we cover up the sensor with this cap. So there we go. Oh, see? It lights up, and it's not crazy bright, but it's definitely a lot brighter than it was. And if I turn off the lights here, it's kind of hard because I still have like my displays here on, but you can see that it shines. So that's about, I think that is about what it used to look like under normal conditions. So yeah, it seems that it's just the voltage on the rail there is just not up to where it should be. So I'm wondering if maybe this capacitor here is bad. Okay, as a test here, I just wanted to see what would happen. I put the positive lead coming from the power supply into the 100 ohm resistor that's coming from the bridge rectifier. So now we've got a voltage that's coming in through there, going through that 1 watt resistor, and then going to the rest of the circuitry. So that means that that shunt regulator there should be working, and it appears that it is, because as you can see right there on the corner, it says 3.357. However, the power supply is set to 6.56 volts right here, and I have it limited to 30 milliamps just because I don't want to blow that shunt regulator. So it appears that everything pretty much like north of the bridge rectifier is working, which kind of leads me to believe that, yeah, maybe this capacitor there is just not working properly anymore. They do degrade over time, so I mean, that is a possibility. But you can see that, yeah, if I cover this up, that LED is working, and it's about as bright as it should be. So the original cap there, even though with the DIR-EE meter, it was reading kind of low, it's probably not the problem because we saw that it made no difference when I put the other one in there anyway. We can verify that it's not the bridge rectifier that has an issue or a bad diode there by setting my multimeter here to diode check mode. And you see I have it up here on the top right corner. except that it was disconnected, so it wasn't doing anything, but there we go. It's up again. So we can check it by taking turns connecting the positive and the red and the black leads to various points here on the bridge rectifier, so we can check each individual diode and make sure that nothing is bad here. So I'm going to start by checking, let's see, we'll check the diodes. Let's check this first one here between 1 and 4. So I'm going to start by putting the black lead here on pin 1, and then I'm going to put the positive lead on pin 4. That would be these two pins right here. So pin 1 and pin 4. And we see we've got 0.5984 the diode drop there, so that diode should be fine. And the next one we'll check is between 4 and 2. So I'm going to put the negative lead on pin 4. I'm going to put the positive lead on pin 2. So negative lead on pin 4, positive on pin 2. Here we go. So that's pretty close to the first one, so that's totally fine. Now we're going to check positive lead on pin 2, negative lead on pin 3. So positive lead on pin 2, negative lead on pin 3. 0.6009, that's close to 0.59 whatever, so no suspicions there of that being bad either. And the last one, we're going to do positive on pin 3 and negative on pin 1. And that's going to confirm that all 4 diodes are good. I'm assuming this one's not bad, so let's go ahead and check. So negative on, or positive on 3, negative on 1. Here we go, positive on 3, negative on 1. And 0.5942, so yeah. So no signs that there's a problem with the bridge rectifier. And this resistor here, we didn't check the 100 ohm, but I don't suspect that that's going to have a problem if it worked with the other power supply. So there we go. So yeah, 100.027 ohms. That's really good. So no issues there. So that pretty much just leaves us with that capacitor, because obviously there's nothing wrong with the fuse. If we check that, I mean, yeah, that's pretty much dead short. So fuse is good. So I removed this capacitor, and I mean, it could kind of be checked in the circuit. The only thing that's in parallel is that resistor, but just to eliminate anything, I pulled it out, and there's actually something here that says Leon. So www.leon.com. Maybe it's Lion, whatever, because, you know, light makes sense. Let's see what DAR EE has to say about this capacitor. So I'm just going to hook it up right here. And it says 457 nanofarad. It's rated for what? 470? Yeah, so I took the capacitor off the board, and I looked through my little bin here where I have like a bunch of some of those film caps and all that stuff. And I don't have one that's exactly the same. The closest actually I was able to find is this one here. This is a 560 nanofarad capacitor, so it's just under 100 more than the original one is. Now, coincidentally, I just happen to have this other board here from another video that I'm working on, and it had a capacitor on the board too, and this one is another 470 nanofarad capacitor. However, if we check this one, it's even worse than the other one. So it I'll show it to you in circuit here in a sec. But this one here, this 560, if we measure that one actually is somewhat close to what its rated value is. So let's try putting this one in line and seeing what happens. And then after that, we'll try this one and see what happens. All right, I wasn't exactly sure how I was going to do this because I didn't want to be holding this board while I'm trying out the different capacitors. So what I did is I set it here on top of that little plastic lid. Then I put this little piece of black foam, craft foam over it just to kind of block out the light a little more. And then I have the LED bouncing off of here. There's a little mirror here that I've angled so that it's pointing straight up at the camera. And what I'm going to do is I'm going to take turns clipping the capacitors here to these two alligator clips, and these are in line with the neutral. Remember, people, I do my own stunts here. Don't try this at home. So when we hook this up, we should see the LED there light up a little bit. And remember, this is the original capacitor. So here we go. I'm going to touch it there, and you can see that it glows very, very faintly. So that's pretty much what we were getting normally. So now I'm going to take this capacitor off, I'm going to put the 470 that doesn't measure 470 from the other board. And let's try that. Let's hook it up. Here we go. You can see that pretty much the same thing. It just kind of barely glows there. Sometimes when you get it just the right, I guess, part of the cycle there, it kind of lights up a little more, but it's still very, very dim. It's actually worse than the original. So now let's try it with the 560 nanofarad capacitor, which is huge because it's a 630 volt one. And then, there we go. We see that. It's, I mean, like I said, it's really hard to get here because it's too bright in here, but you can see that it's actually lighting up how it normally would be under a normal operation. So it does appear that the culprit here is definitely this capacitor. Now, unfortunately, I don't have like a nearby electronics store or anything like that, and I'm not about to place an order for just one of these capacitors or something like that. So that's pretty much going to do it for this one. It appears that that capacitor is the problem. If I end up needing to put like a parts order on like Mouser or DigiKey, you know, or something, then maybe I'll throw in a few of these and then I can swap it out. And hopefully this is going to work normally again. But for now, this video is long enough as is. I really was not expecting it to go on this long. I think it's already past the 30-minute mark. But if you've made it this far, then just know that I definitely appreciate you sticking around. If you like this kind of stuff, remember to smash and annihilate that like button. And if you don't like this kind of stuff, make sure you annihilate that like button anyways. Thank you all for sticking around and watching once again, and I will see you all around the bench.